Hey, how are you? It's April 29th, and I'm going to show you one solder joint, step-by-step process, how we go about doing this. As you can see, I'm not standing. This is my whiteboard back here. We're not going to even use it. It's just me talking and telling you the steps on how to solder. And we're going to do a horizontal joint, and this is my makeshift workshop. So first off, you can see the copper here is dull and this is already shiny. This is already sanded. This has got the excuse me. It's not oxidized anymore because we sanded it off. This is the raw copper. This is what happens when copper hangs out and is exposed to oxygen. It gets dirty, oxidized. It has a layer, a film on it. When you purchase copper, it looks like this. It only looks like this because they put a film, like a polish, like a wax, like when you buy an apple and it looks all shiny, they put that wax on it to make it look that way. That's what they do to copper, okay? So I went ahead and sanded it to show you the difference between the two. And as a matter of fact, the copper joint that we're going to be using is an MIP. The MIP is male iron pipe, okay? And that's the threaded portion. It's tapered so that it tightens as you tighten it in. It gets tighter and tighter. And I went ahead and I sanded the inside of this as well. I hope you can tell how much cleaner it is. So, anyways, before we do that, I believe the first step was what? Measure and cut. Measure and make your mark and cut. And I'm not going to cut with a tubing cutter, like your standard hand tubing cutter. I'm going the lazy man's way, and it's going to get a little loud. A lot of this demonstration is going to be loud, so what we're going to do is we'll go ahead and make a cut to show you what this cordless one does. It goes up to 1 inch, and this is 1 inch pipe, okay? So it cuts, and it cuts it square. You can see this was cut originally all crooked because that was used. I used a Sawzall for that. But this side is nice and square. But it leaves that burr on the inside. You see how it's got that? In here, you could actually cut yourself with that. And that little burr on the inside can actually cause turbidity inside as the water flows across. It's going to hit that and it'll create like a little cyclonic action, and that will increase friction loss, could increase or decrease your velocity, and it could, because of the water, could end up weakening the joint, not necessarily here but down the line. And that's because of, think of it like the Grand Canyon, okay? The Grand Canyon was forged and made from water, just water flow. So as water flows through, it tears away at the walls of whatever it's going through. It'll do that to the copper. So you want it as smooth as possible as it's traversing through the system. Therefore, you got to ream it. So hopefully you can see how this is going to get reamed out. Did you see the shavings? If not, here, look at that little curly Q. See that? That came out of this inner pipe. Now it's all smooth. So that is that. So back to the soldering process. My handy little clamp. to keep it steady, because once you do the attaching and everything else, you have to support it, right? The flux has to be water soluble. You can't use an oil-based or petroleum-based flux. We used to use that a lot 25, 30 years ago. There are still a lot of plumbers out there that prefer petroleum-based flux. It's oil. It doesn't wash out with water, so it actually stays inside the pipe, and it can be extremely corrosive over time, which would weaken the joint, weaken the pipe, cause a leak. So what they want you to do is start using water-based or water-soluble, so that when you do solder and the water goes in, it flushes everything out, okay? And it keeps the system clean. You don't need a lot of flux. Now, I don't know if you saw that video that I told you to watch. They actually used way too little, because you can see they didn't get full penetration, full coat. You kind of want to make sure, let's see if you can get it, that you get the flux all the way around, but not too much. You don't want like a whole bunch flying all over the place, okay? You just want enough. And I will sit there and I'll put this on, put it together, wipe the excess off, okay? And then I want to do something to this part of the pipe. So this is going to go together. Full depth of the cup. Got to go full depth. And then we're going to wipe any excess off. It's important that you do that for a couple of reasons. One, you don't want it to, especially if it's on a vertical. So if it's in the vertical like this and you don't wipe off any of the excess flux, as you heat this pipe, the flux is going to melt. It's going to go right down the pipe. The solder, which is the filler metal, which is this thing right here, the flux helps this go into the cup. If you have some flux going down the side like that, the solder is going to trail down the pipe, and it's going to look awful. And you don't want your solder joint to look horrible. You want it to look fair, okay, or really, really good. And all you can do is hope for, every time you solder, I don't care how many years you've done it, you always hope for a really good solder joint. And you expect a good joint, and you hope for a good one. And every time you do a good joint, it's a great feeling. Okay, wait. Every time you do a great solder joint, okay, we're strictly legal here, right? You know I don't go for that kind of stuff. Okay, so one of the other things we need to do prior to even starting our torch, make sure you have a fire extinguisher, okay? I was told this by my wife. She was like, hey, you're in the garage. Don't burn down the house. I'm not going to burn the house down. Don't worry about it. Okay, now, this is a 1-inch solder joint. If you looked at the table that I told you to look at, it shows you approximately how much solder is required per cup. And for a 1-inch solder joint, you need about 1 1/8 inches for the whole cup. So, do I need this much solder for this one joint? No. You only need, right about there, about that much. Just this much right here. Okay? That's all you need. People have a tendency, if they don't know what they're, they don't know the process, they don't understand the whole concept, they'll keep feeding and feeding and feeding. Where do you think that's going? It's going inside the pipe. And remember, the first step was to ream the pipe. You have to ream it. If you don't ream it, you get that turbidity, you get that cyclonic action, you get that disturbance in the flow, okay? I want to put this right here while we talk. Flux on this doled out copper. Let it sit there for a little bit. So like I said, that's why we ream, right? To make sure you have a smooth flow, less friction loss, easy. You're not gonna ruin the pipe. if you solder and you continue to solder, you continue to feed that in, and it's not dropping out, at the bottom. I mean, obviously it will because you're putting way too much in, but it's also going inside. And when it goes inside, it sits in there, and that whole glob of solder is now creating that turbulence that you don't want. So just realize how much solder you're supposed to be putting in. Okay, it matters. It really does. I can't tell you how many fittings I've actually cut to see exactly what was going on, with the expectation of seeing solder in there, because it doesn't leak here. After it holds and you pass test and pass inspection, chances are you're not going to get a leak here at this joint. Okay, you'll get a leak over here, or if it's a 90, you'll get a leak in the middle, the back of the 90, where there's no solder. It's because that water created that and just ground it down to where it was paper thin and then blew out. So you got to be aware. Okay, so let's take a look and see what this flux did. I don't know if you can tell, so I'll just take this off. Take a look at that if you can. I know the light kind of sucks, but you see how it's cleaned that spot? It's cleaned it out, and it's gotten rid of that top layer of oxidized copper, because flux is corrosive. Just imagine what it would do if it just stayed there. So it's important, after you're done soldering, to clean your fittings. Flush them out as soon as possible. Flush them out. I know that at times it's not that easy because you're, 5 months later testing the whole system kind of thing. But just keep in mind, you want to flush out as much as you possibly can. Okay. So we've cut, we've reamed, we've soldered, we've cut because we've measured, we've reamed, sanded, fluxed, supported, and now we're ready to heat. I'm going to use this because it's what I got. And this solder is Bridget brand. One of the better ones, I think. Canfield, that's a good one. So this is a MAP gas. This is a Turbo Torch brand. I have Goss as well. Those are the two most common torches to use. I also have this one here, which runs off of a hose. And this also ties into a MAP gas. Okay. I have one that hooks up to an acetylene tank. I have a lot of different torches that I've kind of accumulated over the years. And yet, when I need it, a lot of times, I don't have it. Fortunately, I got this. So anyways, here we go. This is where it starts to get loud. It's going to get pretty loud while I solder. But just realize, if you can't hear what I say, I'm starting the heating process in the tubing, and I'm going to draw the heat into the cup. Because if I heat strictly just the fitting, the heat transfer from the fitting to the tubing is going to be so much that the flux is going to evaporate. So what you want to do is like I said, you want to heat this and draw the heat into the cup. And then you can heat the fitting and draw everything in. And when I apply the solder, I'm going to be applying it from here, right about 5 o'clock. Actually, I'll be starting over here at 7. And then I'll be going around. And then I will start here and go around this way. Therefore, finishing the joint. And then I'm going to let it cool to where it becomes solid, okay? Because the one thing you don't want to do is you don't want to immediately cool this, because when you do that, look at it like this. Okay, molecularly speaking, solder in its solid state the little molecules and little atoms and everything, they're in here, right? They're nice and tight. They're moving, but they're solid. When you convert a solid into a liquid, the molecules separate and go further apart, and they really start to move, and they're moving, right? So they're out this far away because it's liquid. As it cools, it slows down because it's solidifying, and the atomic molecular structure is going back tight. But if you're out here, and before it has a time to naturally cool, you're way out here, and all of a sudden you shock it, guess what? It's a weak joint because the molecules are too far apart. The atomic structure is broken. They need to be tight, not apart. So you got to let it cool naturally. It's the best analogy I have to explain it. So don't sit there and right when you're done, squirt it with a freaking water bottle. Don't do that. Please. Okay. Let's do this, huh? Now this torch, it is a little old. It has an automatic igniter, but the igniter doesn't work anymore. So I have to go with the striker. Okay. Eye protection, these being prescription, they're still safety. They're impact glasses. So you should have gloves on. Bare hands, probably not the best way to do this. But I've done it a few times. I've burned myself quite a few times too. So do as I say, not as I do. Wear gloves. Now, like I said, this thing's dirty. You don't need separation like that. You actually want it to look like this. It's going to get really loud. So, like I said, I don't know if you can hear me or not, but we're going to go for it. The cool thing about this is this rotates. You don't want the tip way out here. The flame's not going to work out here. It's got to come in. Right where this flame, the blue, that's how hot you want it. That's how far off. You want that flame to look right like that. If it looks like it's getting too hot, you can remove the flame. You can put the flame back on. It's not that bad. If you overheat it, it's bad. Don't overheat it. What I just did there is I took this and I rolled it on the bottom to get rid of any of the extra that's hanging instead of flicking it. Because you'll see a lot of guys after they're done soldering, they'll flick like this and flick it out. The problem with that is if there's somebody below you, you're flicking solder all over them. So what I've learned, and it's funny because I didn't learn this until way later, I was working with an old timer and I watched him do this. He ran it back this way, parallel with the joint, and it collected the solder on top of the solder. You see that? So instead of flicking it all over the place and getting it on the walls, he collected it on the solder, minimizing the mess. I've had guys soldering for me on projects and they flick. And when they flicked it onto the wall. You see? See that? It comes right off the solder. And this is what you have left over. This, when it's molten and hot and liquid, and you flick, if over here on this cabinet, if this was all like finished wall, and you're flicking solder, you're going to spend the next 20 minutes picking pieces of solder off the wall, which is what we had to do. So, yeah, try that. Try rolling it back, and it should be good. Okay, so this should be dried up enough, or cooled off enough to where we can go ahead and clean it. Now, the larger the pipe, the longer it takes for that heat that generates to actually cool off. Okay? The heat distribution on it absorbs a lot of heat. It takes quite a while for that heat to completely dissipate. So this is the finished product. Let's see. Not bad. Pretty good all the way around. If you can look on the inside, hopefully I cleaned it out enough, you can see the silver as it went all the way through and penetrated all the way in. Okay, and I don't know if you noticed, but I didn't get very much drippage because I knew exactly how much I needed to put in there. Okay, so that is your soldered joint. I know I gave you a bunch of assignments. I gave you some questions and that kind of stuff. That'll be in the email either tonight or tomorrow. I'll get it to you though. Okay, I'll get you the answers to the questions that I asked. Like I said, I'll just go over it and write the answers in the email. If you haven't already, subscribe to the BG's plumbing class so that you guys can go straight to it and watch whatever videos I have for you. If you haven't noticed already, I've got Plumbing 1 and Plumbing 3. If you want to look at the Plumbing 3 videos, you can go right ahead and do that. It's fine. Hopefully you learned something out of it. If you have any questions, I do want you to make some comments. I want you to go ahead and ask the questions in the video, and I will answer them, I promise. Still waiting on some resumes. And actually send me an email if you could. Tell me what you think. Tell me what I need to improve on. I've already gotten one critique, and it was pretty good actually. I enjoyed it. And one of the concerns was lighting. This lighting is not typical. It's not normal, and I'm working on it. And also, I'm working on acquiring an overhead projector, a camera, all kinds of stuff that I need to do in the interim. So I'm doing what I can under such conditions here. And I appreciate everything you do. I appreciate your patience, and I appreciate the fact that you're still checking in, you're still looking, and you're still learning. And criticism is wanted. Please, any ideas that you have that can make this a better experience for you, I would love to do. Okay, so email me a response. Well, you have to do that anyways to make sure that you're actually here. And I guess that's about it. Once again, that's the soldering process. So I think that's it, man. I'll see you guys next week. And again, like I said, subscribe, email, comments, whatever you can do, please. The whole process here, everything that we're doing, it's all new. It's brand new for me. So I need input, please. I appreciate it. Thank you, and I'll see you guys next week.